So it's well understood that in the early years in your career, these are the most important years. What you see and what you experience will form many of the habits that will last you through your career. What I'm going to present here today will hopefully be some points that will put you on the right path to forming useful habits to ease the challenge of being new to a career. I've been in industry for nearly 25 years, as you just heard, and by no means can I say my career is perfect. That's because there's no one way to define success. Everybody's going to have their own definition, but it has been varied in its experiences that I've had and in the challenges that I've seen. So as we go through the talk today, I'll use some examples from some of the jobs, the tasks or roles that I've been in where things were hard because I hadn't done or didn't know something. And I'll highlight some where it worked out well. And maybe by the end of the day, you'll find some of these pointers helpful. Maybe you won't, but we're going to go through them and we'll see how that goes. So, how to avoid faking it until you make it. It's a common enough phrase, and it leads on from others such as sink or swim and trial by fire, and stems from the idea of not being adequately prepared for what you're being asked to do. And while faking it until you make it may, currently be, or as recently what some of your reality has been, it's a scary place for you to be, and the results from which can be equally scary for everyone around you. Well, I'm gonna have a fire truck go by, so you'll hear that for a second. Can you imagine if you need to go to the hospital and are taken into surgery and your surgeon is faking it until they make it? That could have some really bad outcomes. So the medical profession puts in guardrails. Just pause a second while the fire truck goes by. Sorry, that's what happens when you have a downtown office and you're right on the route for the main hospitals and fires. Okay. So I was mentioning here about, you imagine if you go to a hospital and you're taken into surgery and your surgeon is faking it until they make it. It could have some really bad outcomes. So the medical profession themselves put in guardrails. You typically assist in a specific type of surgery before you perform it. And before you assist in it, you read up on the procedure, and so that you know what's going to happen at every stage. And we're supposed to do the same. Being a professional, or even being a person studying under a professional, being in the EIT or GIT program, you are supposed to have some form of guardrails. There are still moments, though, when you're standing out there on a ledge having some decisions that need to be made, and your hand isn't often being held so tight as those newly minted surgeons. So as we talk through some of the points in the slides I'm about to show, I'm hoping you can use them to take you to that make it stage without the need to fake it. I'm going to cover 10 points. They are loosely in order of when you might need to be aware of them. And as you go through the first 10 years or so of your career, except for maybe the last couple of points which are ubiquitous all the way through your career, you might find that some of them become more useful at some points in time. Some people might experience them in a different order, and some might group several of them together at times in their career. So here we go. Point number one, recognize your weaknesses. You'll have many. And the biggest one is that you are inexperienced. You've spent years in school. Maybe you've done a few summer jobs or had a position with a company for a short period of time. But understanding the theory doesn't cut it. There is a big difference between theory and actually knowing how to do something. I grew up in Canada while my wife is from the UK, and I'm an engineer, my wife isn't. So when I needed to go down to Argentina for work at a remote site, I needed to learn how to drive a manual transmission car, as that's what was available to rent down there, and it's what is very common in many, many parts of the world. I've been driving a car for over 10 years by then, and I know how manual transmission works. I understand the cycles of an engine, how planetary gears operate, how a clutch plate works, and the like, but I hadn't driven a manual car. My wife, on the other hand, growing up in the UK, that's what she drove all along with pretty much everyone else in the country. So I had her show me, had her teach me. Now, as I said, I understood the concept. I was able to get off the line, get driving, step off the clutch, drop it into gear, and was driving almost immediately without any real problems. However, every time I came to a stop at a red light, the car would stall. And it was embarrassing. I'm there in traffic and I'm not even bunny hopping, I'm just stopped. I had no idea what was going wrong, and my wife sitting in the passenger seat beside me, she didn't either. Until, of course, she mentioned, you are putting the clutch in fully before you come to a stop, right? And no, I wasn't. Nobody had explained that to me, and it wasn't part of my understanding of the theory of how an engine or transmission works. I was inexperienced, and she just thought it was something that you inherently just know what to do. She couldn't explain why. She had no theory, but she was able to actually successfully drive the car, not I. Okay, of course, once I had that minor tidbit of information, I was good to go and everything went smoothly. So one of the most important lessons you can have, not just as an engineer or as a geoscientist, but as a human, is to be humble. Don't believe you know everything and be willing to learn. Your education may have given you a particular role, but someone who's been in the trenches doing the actual work may have all the answers, even if they can't explain why. And with that, get dirty. In the photo on the right there, I'm wading in a pretty stagnant pond, looking for where the pipeline is and trying to determine if it's buried. It's gross. My partner and I took turns each day with who was writing the notes and working the laptop versus who was waiting, and someone needed to get in the pond, so why shouldn't it be me? Yeah, I may have had more education. I may have done more things. It was my turn. Time to get dirty. Don't stand on the sidelines. Get involved. You'll get more help from the people around you if you're willing to work with them than to stand off on the side. Don't just be an observer. I've been with many junior staff who have had to suggest it to go work with the drill helper. Help them out. Help carry the rods or clean and reassemble the soil samplers. Don't just be a witness. Get your hands wet, make their day easier, and be seen as part of the team. Those who help get told the important information because the driller respects them as a colleague, not as an outsider. They will tell you when they are seeing increased pressure on the rods or feeling chatter in the drill bit, telling when you've encountered different materials or encountering a change in units. If you stand on the sidelines, not being their friend, you won't get any of that. So be humble, be part of the team, and bring donuts. You make friends that way too. Do not underestimate the power of donuts. It's an instant icebreaker and puts you immediately onto the side of the team rather than, standing back and being separate. Spend $10 on a box of Timbits and you'll get $100 worth of information and favors back. It's really a helpful tip. And I put this bottom point there, but it's one you'll see me echo through many of the slides. Not knowing is okay, but not asking for help is not. Recognize when you're in over your head. Be cocky about it. If you fake it, just like that surgeon situation, you could end up risking your safety or others. You could waste a lot of time and effort and end up with something being constructed that doesn't meet what the design intent is. You can go way down a path before somebody else realizes you don't know what you're doing. You've been given the opportunity because you have the theory or the background. But we'll now walk through some of the solutions for what happens when you don't have that experience. So what is experience? It's what you get when things don't go exactly to plan and when you see things through all the different permutations that are out there. I'm experienced in undertaking fieldwork in pretty much all conditions. I've worked outside in Alaska in the winter, in the foothills of the Andes and in the jungle of the Amazon, along with many other interesting places. I've been up in the mountains in the high altitude in Kyrgyzstan. What that has allowed me to do is to take the knowledge from one situation and start to port it to another. And with more and more experiences, you can make a more accurate assumption on what to expect when you get to a new one. Don't turn down field work, as you are only as good as what you've done. When I finished my PhD and returned to Canada, I had done some technical work as part of summer jobs during my undergrad. I did some contract work during my master's and my PhD, but I had done very little field work. It was all work in labs, work theoretically, calculating things. Yeah. And I recognized that that was a serious weakness in my experience.
So much better.
I could run the computer model or calculate the, watt out of something, but I didn't have the gut feel for if the numbers I was using were real. That needed field experience. It was a hole I had. So I made it my role to be the company's field guy. If there was field work, I wanted it. I recognized that was my weakness. No matter where or when or how uncomfortable or boring it might be, I wanted to go. And so within just a few years, I had built myself up to a reasonable level. And with the pun intended, it set the groundwork for a lot of my career. I can now visualize the materials, what a till looks like, or a deltaic sand, what its conditions might be. I can foresee some of the challenges, like how drilling may be more complex in the Alaskan winter when you have less daylight, or the need to drill with brine, so a salty water, so that the freezing point is depressed and you can still use fluids to flush cuttings rather than having everything freeze up. You get that through experience. It helps you on the technical, it helps you on the non-technical. In the bottom left photo there, you can see me walking on a riverbed there, river floodplain, and I was routing a pipeline in Bolivia, trying to avoid all sorts of geohazards, trying to figure out the best way to cross rivers and through across a mountain range. And one day we were hiking up this slope, and I looked back, and there was a guy with us who was carrying a small can of paint. He was using a paintbrush to mark on trees as we went by. We were out there as a big group of people. And I asked one of our client reps who was out with us what the marks were for. And in my mind, I thought he was like laying breadcrumbs so that we could mark the path we'd hiked. But that seemed a bit strange, as I had a GPS and I was placing waypoints at the important features. It turns out he was literally marking the route the pipeline was going to run, so between individual trees, and that the surveys were going to come back behind later and pick up those points. Unfortunately, I had to break it to that guy that sometimes it's easier to hike up a hill on a diagonal, but we still wanted the pipe to run up the hill. So with that, you realize that your field work can also let you build some softer skills. You have to learn to communicate people, to recognize the challenges. You need to manage your time and your fatigue, figure out things like doing laundry or packing for when you're going to be away for weeks at a time. So there are soft skills that come with working out in the field and getting all this experience that you also gain. Having to figure out how do you work long numbers of nights or long numbers of days. Maybe you're on night shift. You also learn to critically assess the work going on around you, not necessarily just for its technical aspects, like why is this guy marking a path up a slope that we're walking up on diagonals and making it easier to walk, and realizing that that's not going to be hopefully the way the pipe would actually run up the hill, taking 200 meters to one way and then 200 meters back the other way. Recognizing that the overall objectives are actually making sense when you're in the field compared to the mental concept that was thought through at the office. Those sorts of skills are really, really helpful. But recognize that your weakness can also be your strength. You're all relatively fresh out of school, or maybe even just graduating. Understand that the state of knowledge is always increasing and some theories get disproved. When I was doing my undergrad 30 years ago, yeah, I'm old. The textbooks discuss that the theory that from the formation of the moon was part of an accretionary process, much like the Earth when all the planets were forming. The spinning disk and material just kind of formed and clumped together, and you had the planets and you had the moon. Nowadays, that leading theory is not the one. The leading theory is that we had a proto-Earth, it was collided into by another body, broke apart, and some of the fractured crust coalesced into the moon. So understand that those with more experience may not have the latest information, and that textbooks go out of date quickly. If you look back at your textbook, it may be the 10th edition on something, and it's been revised every 2 years, but the core of that textbook may be more than 20 years old. And those updates are minor typos, the odd new example and things. They're not a full rewrite. These things go out of date significantly. But in all likelihood, hopefully you've been trained in the latest techniques. Right? You're a recent grad or you're still in school. But your supervisors, the people you're going to work for, may know of new techniques, but not how to actually do them themselves. Alternatively, they may be relying on a technique that was cutting edge at the time when they were in school or the last time they took a course and has now become outdated. So on the left here, I've got an output from a FLAC numerical model of a slope during an earthquake, showing the displacement on that slope. Being able to run these models is now commonplace for new graduates, being taught in university at all levels. There will always be specialists who are keeping up with techniques, those that are advanced through their career, who go back to school or read the manual and actually put themselves through training on things. But in general, those with more experience won't necessarily always be able to do what you can. They know what you're supposed to do. They just don't know how to actually do it themselves. So being new is a strength. It's a strength of yours, not a weakness. Now, for those of us who are old, help us. Wow us with how you can take what you would have taken us hours or days to do and use a Python script, for example, to solve it in minutes. Don't ignore those skills. Be polite about it, but do bring up when things can be done more efficiently. It's not always a weakness that you don't have that experience on how to do things the old way. Okay, on to point number 2. Don't worry, they do get faster as we go along. Do your research. Anytime you go onto something new, figure out as much as you can about what's going on. Find about what you're actually going to do when you go somewhere or get onto that role. Have there been any challenges that others have noted about what you're going to do? About 4 to 5 years into my career, I was on a job in Brazil. It was for a mine where we were investigating the foundations for dams and some of the facilities that were there. And so we were doing a lot of test pits. And after only about 10 minutes in the field, looking at the photo on the top left, I was covered in this red clay soil. It got everywhere. It never came out of that washing. It was horrible. And it was nothing like the dirt in Canada. This stuff hadn't seen glaciers and it was old. So this was tropical residual soils, something I had no knowledge of. All my undergraduate, graduate training, none of it had covered this type of material. It was all stuff that had been glacially worked over or river deposited. It was nothing like the stuff that I was seeing here. Fortunately, each of the team that had gone down before me, and I was just coming down as one of the next ones along on our a conveyor belt of staff that were coming and going, they had passed down to the new person some information that was key to understanding these materials in the form of a photocopy of a chapter of a book to read on the plane down. If they hadn't given me this information, I would have been pretty lost. In that chapter, it had that chart on the left, showing what the typical weather and profile looks like for these soils. You can see core stones with weathered soil rinds around towards the bottom, and progressively more and more weathering as you rise up through this profile. So you get towards the surface, the newer materials, the stuff that's had more chemical action in this case. If I didn't have the chart and hadn't had any experience in it, I would have just been guessing and faking it while I was down there doing test pits. The pictures on the right show what it looks like in real life. You can see those cores of material, of solid rock still, with an erosion around it. It does look a lot like the photos. That did not look like a test pit or any sort of soil I had ever seen before. Even at the shallower surface, the areas that were eroded, the chemical weathering that had gone on, left these darker stained areas, which were originally pieces of rock. The soil had a texture. This is the book that the chapters came from. And I think it's still a free download from the UK Geological Society. So if you're working in tropical regions, this book will help you immensely. But the key here is before you go anywhere, get some background information. Ask your teammates, is there anything I should read or anything I should know? What's going on down there? Who's been having a hard time or why? And try and work your way out through it first. Look up the geology. Find some imagery if you can. Figure out what you're doing so you're not just thrown into the deep end of the pool and you're like that I think it was a pug, that dog, floating around in the water, scrambling, going like, why am I here? What's going on? Eyes wide open before you sink. So, point number 3. Be prepared for the unexpected. You've gone through a very protected and sheltered education. What do you mean about that? The problems that you've had to solve typically have been really idealized and simple examples. That's because they need to make sure everyone understands the concepts. Then if they have time in their class schedule, which professors almost never have, they can start to throw curveballs and make the problems more complicated. So they try to make it so that everybody can actually understand and get through the questions a reasonable amount of time. The real world's not anywhere near so simple. The geology can be much more complicated. You have limited budgets and you have to make assumptions. So we might have one borehole and you generate a cross section, very simple section. You don't know if anything's tipping or not, so you just draw it straight across. Perhaps your project, you can afford 2 boreholes. Well, now you got a different conclusion on geology, possibly. Okay. Maybe you can do 3. Now you're really starting to see something more complex. In these cases, the budget you're given, and it's likely that the more senior person you're working with has been setting the budget or working with the clients and deciding what you need to do and where, will determine how you're going to do this analysis. This lack of information or imprecision in understanding is going to give you uncertainty in the results and the decisions that need to be made on whether to do things like take an upper or a lower bound or an average. And there are going to be even time constraints with clients or operators needing answers by a certain time. Maybe you don't have time to drill 3 boreholes. Maybe you have to make a guess. So all this means you need to set realistic goals and to be prepared for compromises to be made. But don't take it personally when unexpected conditions arise. It's really very rare that it's as simple as it was in the textbook that you had going through your education. In 2003, one of my early projects was determining the seismic hazard for an oil pipeline, Trans Mountain Line, that crosses underneath the Fraser River near Vancouver. After determining that the liquefaction and lateral spreading hazard should a large earthquake occur was too great, the pipeline operator, Trans Mountain, decided to replace the pipeline with one installed by horizontal directional drilling, or HDD. This is similar to tunneling, in which you have a deep path that gets bored. The drill starts off on a flat angle, not as flat as it looks like in this picture. Sorry, not as steep as it looks like in this picture, but it goes down, curves, and comes out at the exit point. And it goes from one bank to the other, running far enough back and deep enough that you avoid the, in this case, seismically susceptible materials. Now, this replacement was going to cost several $1 million. And so we drilled 14 boreholes, including some from a barge in the middle of the river, to give us a detailed understanding of what that geology was looking like. And there are layers in there of sands and silts and gravels, and it's a fluvial environment. So you do get a significant variation in the geology, both horizontally and vertically, because over time, the river spits out different types of materials. And so that's what you can expect from nature. The geology is complicated. Now, this information was provided to the pipeline operator, who then gave it to the construction contractor. And in 2005, off they went to construct the crossing. We weren't involved in the construction. We were the engineers, did the investigation, gave them the analysis, and they said, thank you very much, and did their stuff. But I tried to keep an eye on what was going on the side, and it was, this is very public, what was going on, so I could drive past the site and see things. But a few weeks after they finished, I received a phone call, a very panicked call. Sinkholes had begun to open up near where they installed the crossing, near the exit side in Coquitlam. And they wanted our help to determine what was going on and how to stop it. These sinkholes, they looked like manholes, the ground just disappearing beneath. And they only showed up when the asphalt gave way. So the city of Coquitlam, they closed the roads down in the neighborhood. They were afraid cars were going to get swallowed up. So what was happening was that material had been lost into the annular space around the pipeline, which was notably smaller than the size of the bore that was drilled. So in the HDD installation technique, you drill a path and then you pull a pipeline into it. But because the ground might change and squeeze down, or you might have material drop in, you make sure the hole is significantly bigger than the object you're going to pull through. You don't want friction to stop you from being able to pull this drill pipe in, or this pipeline in. And so we were seeing collapse. The material was piping back out to surface, and that was sucking in to basically make these voids. Now, ideally, depending upon the geology you're in, the annular space is stable, and in other cases, they use drilling mud to, solidify the space around it. Mud is clay, basically, and over time, it holds and buffers it and allows for the pipe to still sit in there. And ideally, you pump it full so the whole thing is basically encased. But we found that some challenges were occurring, leading to these sinkholes. So I had them excavate down to where they could restore the road and the ground beneath. We opened up some pretty big excavations, looked at what was going on in the ground, figured out the problem, started backfilling, and stabilized the ground. But there were many places where they couldn't reach because it was just too deep. That pipeline is running tens of meters below ground until it comes back up to surface at the entry and exit points. So we had to do a grouting program. We had to pump cement into the void, stabilizing the area. And eventually we did get it all tidied up and no more sinkholes, and the sign could come down and the neighborhood was back and going again. But maybe you're wondering where the story is going, because the point here was to prepare for the unexpected. And how do you actually do that given what we saw? Well, the story goes a little further. So we jump forward to 2022, just last year, 17 years later. Same pipeline company is now wanting to install another pipeline. This is the expansion of the Trans Mountain system. And again, they're doing it via HDD beneath the Fraser, but it's only 1 kilometer upstream. And now, rather than being the junior person, I'm the senior geotechnical person on the project. So I tell the contractors about the issues that we had back in 2005. I show them photos. And again, we do a complicated and detailed drilling program, including drilling on barges. Contractor goes and does their HDD drill, and sure enough, we get sinkholes again. They look the same, like a manhole. But this time we're prepared. We know what these things are. We know how to solve them. So rather than closing down a neighborhood, we close down single lanes on the highway and patch the issues and carry on. We bring in geophysics that we knew we would have on standby nearby. We run scans down the highway, looking for, do we have any more voids in this area? We can clear it up. We can say no. We can be confident. We can move on. Yeah, maybe reacting like this isn't the most elegant, and it would have been great if we didn't have sinkholes or void issues in the first place, but we were prepared. Amongst our team at BGC, we had discussed this as a potential problem, and we were monitoring for them. And even the most junior members of the team looked calm, cool, and collected in front of an anxious client and in front of the Ministry of Transport's people. So it was important to be able to expect the unexpected, to plan for it, to be there. Okay, on to point number 4. I often get asked for what is one piece of advice I can give to young engineers. Now, I've been asked to give you 10 here, but pick one, this one here. It's be brave and ask questions. No, it's still 1 point. You need to do both. Put yourself into that vulnerable position by admitting you don't know or understand that something is going to happen, and that something, asking questions can be scary. We've all been there. The easiest way to not need to fake it is to understand. And the easiest way to understand is just to ask someone. Most people genuinely like to explain what they're doing. It shows that you're interested. I haven't really come across anybody that would say, can I have some help? No. Can you tell me what's going on? No. Like, what are they trying to keep private? They will help you. My very first job as a junior was working on the SkyTrain expansion in Vancouver back in 2000. We were responsible for the geotechnical design of some of the stations, and these stations had elevated guideway platforms, and the platforms themselves were cut into steep ground, requiring hundreds of tensioned anchors to be installed to hold back the walls. On my first day going to the field, which was just like a week or so after showing up at the company, I was introduced by my boss, who was, president of the company, to the contractor and the client, and then was unceremoniously left behind to be part of their anchoring team. And within minutes, I was being asked a question and felt like I was under the microscope. They had asked me, what sort of testing would I like for these anchors that they had just installed? Now, I had taken some civil foundation classes in my undergrad, so I knew how an anchor could be used to support a wall, but that was just the theory. And here I was being asked a question. I didn't have a clue what they were talking about. So I made myself brave, and I asked a question back to these contractors. What type of tests have you been doing up until now? So, simple enough question. What would you like to do? Well, what have you been doing right now? They said mostly proof tests and some performance tests. And now, giving away a bit of my ignorance, I asked them to remind me on the difference between these proof and performance tests, which was phrased, basically in response of the proof tests are a step loading to measure the creep that all the anchors get. So every single anchor gets a proof test. And that way they can be sure that the load is working correctly and the anchors are all performing. And they said performance tests are the ones with the additional loading and unloading cycles, and that they're previously been doing one test every 10th anchor. Now, that gave me enough information to, I guess, partially fake it until I made it to the end of the day. But I said something to the like of, sounds good to me, and I'll let you know if we need to change it. So I had to rely on the fact that these guys had experience. I had to make an assumption that they weren't trying to pull the wool over my eyes or do anything bad, but I gave myself an out. I gave myself, I'll tell you if we need to change it. And then, it seemed reasonable. So I then went back to my office that evening and I read everything I could on anchor testing so that I was prepared for the next day and the day after that, and so on. So again, I tell all the juniors I know to be brave and ask questions. Asking questions isn't embarrassing, maybe for the moment, but it shows you're honest. The senior staff in an office usually like to answer questions and explain things and why they're done a certain way. All you got to do is step into their office, knock on their door, open it up, be brave, go in and ask. Point number 5, find a mentor and a guru. Start with a mentor. This is not a career to go it alone. You're already trying to break new ground early in your career. You need someone that you can talk to, who you can run ideas past, and who isn't going to stab you in the back. So the photo there is of Mark Lear. He's my mentor. He's a few years older than me, has had many of the same passions over the years, is someone I've been able to talk to freely. Use your mentor as a sounding board on the trivial stuff and the big decisions. Ask them for advice. Check what they think about taking on more work, or how to tell your boss when you won't be done in time. Maybe you work directly for them. Maybe you work on projects beside them. Maybe they're just someone in the office that you can relate to. Make sure you have a connection with this person and get the feeling that they are actually interested in helping you. This person will have an influence on your career. But you're either going to model yourself after them, or you're going to listen to their advice, and that can sway all manner of your professional decisions and therefore your professional life. Ask yourself, would you hang out with them on the weekend? And try to find someone that you look up to and that can actually be your friend. This is a person that you're going to use as a role model in the near term, maybe in the long term, but it's someone that you're going to pattern yourself on. Once you found a mentor, start thinking about a guru. So once a guru, this is a person near or at the top of their career. They are where you want to be in 20 or 30 or 40 years. They're doing the subject or field that you love, something you're really interested in. Now, the connection piece is much harder here for finding a guru than finding a mentor. This person may be significantly older than you, may be harder to relate to, but approach it with the aspect that you admire what they've achieved. You can say you're going toward their vanity, but just ask if they can give you some advice periodically to put you on, hopefully, a similar path. Ask them what chapters or papers and books or papers, the chapters and books or papers would give you a good introduction, and then actually read them. And then ask questions back to them or ask for more. What courses did they take or conferences should you attend? Basically, can they point you in the right direction? So picture at the bottom here is Adrian Whiteman. He's an expert in geotechnical earthquake engineering, among many other topics. A few years after I'd been working on that liquefaction study for the pipeline crossing of the Fraser I showed a minute ago, Adrian joined our company. And so I asked him some of those questions. He pointed me to a great text, which was the proceedings from a workshop attended by some of the top seismic geotechs in the world. They had this colloquium and got everybody famous and important together. In there were some updates on techniques and formulas and discussion on papers. And so I read that cover to cover. Now, after asking some questions back to Adrian about some of the things I found in there and what I should do in this situation or the next, he passed me a paper that I have here on the screen. And again, this one gave a good introduction on how to do the basic analysis needed in the subject. You don't need to be asking for the most complicated things around. You want to ask these people, how do I get going? How do I start down the path? Not how do I take 3 or 4 leaps further along than you should be. Build it up like a framework. And then he passed me a book. I looked through that. I can't say I read it cover to cover, but I did go through a lot of the chapters and saw some stuff that I was interested in, some areas that I thought maybe it's a little bit more advanced. I'll get there eventually. That's the role of the guru. Not necessarily to be your friend, although the more you interact with people, And the more respect you give and get, the more like a friend they'll become with you. But is primarily the role there to inspire and show how to get to those lofty places in the future. So find someone that you can look up to who is that challenge, that not necessarily the mentor, which you should be having a really frequent interaction and relationship with. Find someone that is where you want to get to eventually. Talk with them. That's point number 6. One of the biggest weaknesses that young engineers and geoscientists have is lacking confidence in public speaking. When you become comfortable with public speaking, you also gain confidence to speak up in meetings, in the office and in the field, and you'll start to establish a presence. Get comfortable. Start with speaking in front of your peers. Do small presentations on the work you've been doing, then move on to in front of more senior people that you work with. The pressure will mount as you try to not feel embarrassed. But that's what you're trying to get comfortable with, to get rid of that nervousness, that feeling of embarrassment of what if you say the wrong thing. And eventually, start speaking in front of strangers at conferences or client meetings. It will come. Practice it. Now, there are many ways to learn techniques for getting comfortable. Practice is the best. The more presentations you do, the better. But also look at what others do. You can watch a TED Talk or two, or watch, for example, someone like one of Steve Jobs' recorded keynotes. You can even get books on how he did his presentations, but that's probably not worth it. Or just pay attention to how your colleagues give presentations. Look at what seems to land with an audience and what doesn't. How are they delivering their presentation? What is their timing or their cadence? One of the biggest misses I've seen by people that have been delivering their information is do it at the wrong level to their audience. Know who you're presenting to. Now, this is a bit of a rule I've developed myself, but over on the right, I've listed the different levels of audience. I pick the level of who I'm presenting to, and then I typically go a half step or a full step lower for the way I'm going to formulate the presentation. It's not that I think my audience is stupid. Don't speak down to them. It's just that I've seen many presentations where people overestimate the familiarity of the topic by their audience. Few people are going to know the content as well as you do. So you need to guide them along gently. Don't talk down to people, as I said, but recognize that they aren't involved in it necessarily every day, or that they might be distracted, not able to give you 100% of their attention throughout your presentation. So if you're presenting to an expert, they're at the top of the list. Present to them as if they're a normal practitioner in the subject, someone who is working on it every day. Explain things simply. Recognize that your clients might not have all the same familiarity with the subject as you do, and probably don't have this, may not even have the same degree or background as you do. They may be put in a position to take your report and work with it, but they may not have your background. Likewise, some clients might not even be able to give you their full attention. They could be distracted by emails or calls. So you need to take some of the minute details out of your presentation and just give them the really important nuggets as succinctly as possible. Now, the hardest thing I found, and probably one you will too, is to try to explain to your parents what you do, either in general or with a specific task. The number of times my parents have asked me the same question it's amazing. I discuss it now as if they are elementary students. Tone it down. Recognize basically that you need to tailor your information that you give when you speak. Not just what is it you're talking about, but how do you give it? Recognize your audience. Now, for the next few slides, they're going to typically occur after a few years of work. And the first one here, point number 7, mentor and teach. I've talked about getting a mentor, and eventually it will be your turn to be a mentor. You may not feel it immediately like you have anything that you could offer, but you do. Spend time with the new members of your team and give them the stories of what went right and what went wrong. Being a mentor isn't just about technical teaching, but also how to do their job. You don't need to have someone like me give them pointers. You all will have pointers of your own in a very short period of time. Maybe you already do. But be open and receptive. Put yourself back in their shoes and remember what it feels like to be that deer in the headlights, or to have that 1,000-yard stare where you have no concept of what's going on and you're just blank. Look out for it. Help them. After being the field guy for a number of years, I had gained a reasonable amount of experience, and we started to hire more staff. So I took it upon myself to take the new juniors out to one of the sites I was working at because I had jobs that were quite local. In the photo on the right, one of the staff there was directly working with me, and I was showing them the ins and outs of core logging. But I thought it would be a great opportunity for the whole group of new hires to come along for the day, to learn together and to take some of the fear of asking questions away by having a group, all of whom are at the same level. So now the 5 juniors there in the photo have all gone on to be senior engineers now. Some are still with our company, but all are amongst the best I've ever worked with. I can't say that, it was my involvement made them good, but the little bit of help that they have along the way from people willing to mentor and to teach all builds to make more confident individuals. You should try to give those nuggets of wisdom whenever you can. Now, one other point that I've got there at the bottom of the slide, put yourself into a position where you're teaching is one of the best ways to solidify your understanding of a topic. You're inherently wanting to be right and not be embarrassed, so you're going to prepare and put all the pieces into the right places. If any of you have been in grad school and had to TA a course, you'll remember this. Teaching really drives you to learn a subject. And so you get the benefit almost as much as those you're teaching to. It will stick with you on the answers of what you're teaching. Point number 8. At some point, you need to become a professional. After a few years, you need to ask yourself whether you are just wanting a job or do you want a career. The difference being, if it's just a job, you are there to put in your time each day, clock in, clock out, and get your paycheck. You're only doing the minimum to keep on the advancement path, and your time at work is just a means to an end, being things outside of work, and that's okay. But there's another branch on the tree, and that's for those who want a career. They want to experience greater challenges and learn new things and strive to excel. Rather than hearing that people want to hire a certain company because they're cheap or quick, they want to hear that people want to hire a company because of specific people who are working there, and they want to become that person in demand, but who is respected for their thoughts or contributions. So if you want to have that career, how do you do it? I talked earlier that for many people, their knowledge is as old as their textbooks, and that after 10 or 20 or 30 years, some people might still be doing things the same way they've always done it, irrespective of if time and techniques have moved on. The way to do that and solve that problem is with professional development. Now, this can be taking short courses on subjects you're interested in. They can be a 1-day or sometimes a 1-week course, and they're great if you want to get the latest on a specific topic. Really, really helpful. But I also often get asked about going back to grad school. Is it worth it? And should I do a 1-year course-based master's or a multi-year master's with a research thesis component? So for whether it's worth it depends on what type of work you're doing. Are you going to, or are you planning to forever be the manager of people where you read reports? You just read them, you don't write them. And if so, then an engineering or geoscience master's is probably not all that helpful, as you're going to rely on the people you manage to keep up with those latest techniques. Maybe an MBA is more useful in that case, or just stick with some of the short courses and gain lots of experience in the field. But if you're going to be an expert, working in consulting, for example, which the product you sell is your time and expertise, having further education is often worth it. So the 1-year course versus multi-year research-based one, you need to ask yourself, why are you interested in getting more knowledge? Did you feel like you didn't take the right courses in your undergrad, or perhaps you slept through some of them? And backfill that hole in your education with the 1-year course-based master's. Choosing courses that you're now really interested in because you've had a bit of experience and you can see what is your passion and see what's particularly applicable to you. Or are you passionate about a specific topic and want to be that go-to person? If you do, then you want to take the multi-year master's, choosing a program and a supervisor, much like you would a mentor. But beyond formal education, it's important to keep up with what others in your industry are doing. Start to read the odd article in a journal. Consider writing a paper with a coworker or for a conference or on some aspect of the work you've been doing. And start to attend conferences. They can be awkward social settings for young attendees. I was there, I remember it. Basically hiding in the corner like you're in a high school dance. But some of these conferences even have events or sub-conferences specifically for young people, and those are really worth going to. Also, go to your local CGS chapter presentations. All these things will allow you to meet new people, hear what's going on in the industry, and let you observe presentations, thus back to that earlier point I was talking about, of helping you learn how to speak by watching others. Finally, if you want to have a career, get your professional designation. Without it, you're still in a job, having to work under someone else's supervision. With it, you're on that way to guiding the work you want to do and how you feel it should be done. Point 9, be safe. There have been many studies of statistics on safety incidents that show that the risk to new workers, which are those in the role typically for less than a year, or those under age 25 are at a much higher risk of injury at work sites. It's not that you're more careless than others. It's that more things on your mind, it's that you have more things on your mind than the rest of the workers that are out there who have been doing it for years and you have less experience with what can go wrong. So despite companies all having workplace safety plans in place, you need to look out for your own safety. Recognize that we're all different, and so we'll have different limits, physical, mental, emotional, and don't compare yourself to others. It's okay to stretch a bit, but know when you need to stop before it's too late. Physically, that could be, lifting or carrying and knowing before you hit the limit and injure yourself. Strain yourself, for example, pull your back. Or it could be how long can you hike in the hot or cold weather. Not everyone is at the same fitness, and so you need to know when you need to stop. Same goes for mental and emotional limits. These could be the mental fatigue from working multiple days in a row or having to work nights. They could be in the form of isolation if you're working in a foreign country in a foreign language you don't know. From my own experience, I once worked at a mine in Kyrgyzstan where they spoke mostly Russian. It was Russian or some local dialects. There was very, very little English. And the mine was owned by Canadians, but the group I was working with were locals. So I was there on my own for 8 weeks, and it was quite isolating, never hearing much English around, and only talking to people in some very basic Russian sentences that I could pull together from a dictionary. When I flew back home, getting onto the Air Canada plane, hearing all that English being spoken gave me a headache, as I had been tuning out the voices for the previous 8 weeks. I was just isolating myself. So I mentioned that part of the reason that new hires get injured more is the additional mental draw from starting the role. Trying to remember everyone's names, where do you need to go to get a piece of equipment, the non-technical parts of the job, like where do you do laundry or where do you eat dinner. This additional draw mentally is taxing. It'll make you extra tired until it becomes that second nature. So recognize that. And don't try to do things for the betterment of the project or company when you might get hurt. If you get hurt even 1 out of 100 times, that's not going to help a project or the company. And lastly, it's really hard as someone new not to say yes to everything. But put back in point number 1, don't turn down field work. However, sometimes you might need to. You need to be true to yourself. Evaluate yourself critically and think on if are you really going to be a help or a hindrance in this situation. So my final point, take advantage of being new. There's an adage out there that youth is wasted on the young, and how true that is. There are many advantages of being new to your career that you probably don't recognize. The first is that gaining experience is a double-edged sword. It's great because having experience makes you more valuable. It's also bad because you often constantly more expensive or indispensable to your job or your client. With that experience, you're given more responsibility, which means you often can't be as open to taking on new and exciting opportunities. You can't say yes to everything. You're busy. And eventually, you can literally price yourself out from the field. Clients or even your own company would rather send someone who is half or a third the price to the field if there aren't any real tangible benefits of sending someone with a lot of experience. Why send the most expensive person in the company to go drill a hole when someone who's cheaper can? And that's why you rarely see senior staff out for long periods of time in the field. It's not because they don't want to be there. We love going to the field. But it's rather it's too expensive or distracting to other aspects of their job to keep them out there for so long. The picture on the right is of myself with some of the members of my project team out in the field from a year or so ago. While we're all smiling in this selfie, the one with the best smile on their face is that junior in the back. If I get this guy. He is the one with the most carefree time. He's not having to worry about what's going on. He's able to stay focused on the task. He does not have to worry about phone calls, emails, Teams meetings, all these other things that the rest of us are having to do while we go around in the field. He's there for singular purpose. And this is a location where he's working at, so he can focus on it, and it's great. He's taking advantage of being the new guy. The second real advantage of being new is that you can be open to change. Most companies, even ones that specialize, still have some variety in the workplace. Be open to trying different things. Don't let yourself get pigeonholed, at least not too early on, and don't get in with preconceived perceptions. Gaining a broad range of experience is at or even more valuable as multiple examples of getting the same experience. It allows us to be flexible in changing work climates, as you never know when one industry is going to be hitting its highs or lows economically. and it gets harder as you go through your career. It's easy to start again at the bottom and learn new things when you're only a rung or two up. It's a much bigger deal when you're at the top of the ladder and you basically need to become a junior again. So enjoy the freedom now. Well, that's it for my points. I've placed a list of them here. Again, they're in a loose order for how you might see them in the first 10 years. The exception maybe points number 9 and 10. Recognize your weakness. You don't have any experience, so be humble. Don't turn down the field work. Bring donuts. Donuts are important. Do your research. Get as much information as you can. Ask other people. Be prepared for the unexpected. Be brave and ask questions. Speak up with the people that are willing to help out, and don't try to just fake it. Find a mentor and a guru. Be open, be receptive, mentor and teach. Be safe. Enjoy your career as you're young. Take advantage of it. The world's your oyster, and the experience is there for the taking. That's all I've got, Instar.